Welcome to this video. I am Dr.K.Usha, Assistant Professor of Statistics, Sri Sharada College for Women, Salem. So, in this video, I am going to talk about correlation or correlation. So, before going to the definition, but first we will know about what is meant by univariate data and bivariate data. So univariate data means study about the single variable. Bivariate data means study about the two variables. To find the correlation, we need x and y two variables. So from the two variables only we can find the relationship between the correlation. So if you want to study correlation, first thing we need the two variables. So now see the definition of correlation. To study the degree of relationship between two or more variables is called the correlation. I already told that we need two variables or more than two variables we can use to find the correlation. For example, so I have already told x and y variables. So for x variables I am taking height, for y variables I am taking weight. So here height and weight are related. So this is the example for correlation. So the correlation tell about whether the variables are related or not, but it does not tell about the cause and effect of the relationship. So the correlation used for only the given variables x and y variables whether related or not, but it does not tell about the cause and effect of the relationship. So next one, types of correlation. There are four types of correlation. First one, positive and negative correlation. Second one, simple and multiple correlation. Third one, total and partial correlation. Then fourth one, linear and non-linear correlation. So we will see one by one. First one, positive and negative correlation. So positive correlation means if two variables tend to move together in the same direction, that is the both the variables increase or decrease on the same direction. So if we are taking x and y variables, here x variables increase, y variables also increase, that is the positive correlation. But suppose if x variable decrease and the y variable also decrease, so that is also a positive correlation. If either increase the both the variable or decrease the both the variable, the x and y variables tend to move together in the same direction, that is called the positive correlation. For example, rainfall and yield of crops. So if the rain increase, we will get the yield of crops also increase. Suppose if the rainfall decrease, the yield of crops also decrease. That is the example for positive correlation. Then next one, negative correlation. If two variables tend to move together in the opposite direction, that is one variable increase or decrease and other variable decrease or increase on opposite direction. So in the positive correlation, both the variables tend to move together in the same direction. Here, x and y variables are there. So this variable move together, not move together in the same direction, it is move together in the opposite direction. For example, if x is increased, y is decreased, that is the negative correlation. Suppose x is decreased, y is increased, that is also negative correlation. If the two variables tend to move together in the opposite direction, that is called the negative correlation. For example, price and demand. So in the market, on product price level increase, the demand will be decreased. Suppose if the product price level decrease, the demand will be increased. That is the negative correlation. So next one, simple correlation and multiple correlation. So simple correlation is nothing but the correlation. The relationship between two variables is called the simple correlation. So here we are taking only two variables for finding the correlation. For example, rainfall and yield of crops. For the example for simple correlation. The next one, multiple correlation. In multiple correlation, to study the more than two variables simultaneously. So in simple correlation, we are taking only two variables. In multiple correlation, we are taking more than two variables. For example, rainfall, fertilizer, and yield of crops. So here we are taking more than two variables. So this is the multiple correlation and simple correlation. Next one, partial and total correlation. The study of two variables excluding some other variables is called the partial correlation. For example, rainfall, fertilizer and yield of crops here. Eliminating fertilizer is a partial correlation. So partial means what? So here we have three variables: rainfall, fertilizer and yield of crops. From the three variables, we are eliminating one variable, that is the partial correlation. So given our example, rainfall, fertilizer and yield of crops, I am eliminating fertilizer. So this is the example for partial correlation. Next one, total correlation. In total correlation, all the facts are taken into account. So, for example, rainfall, fertilizer, and yield of crops. So here I'm taking three variables. So in the total correlation, I'm taking all the variables into account. That is the total correlation. In partial correlation, we are eliminating or excluding one variable from the variables. That is the partial correlation. So this is the partial correlation and total correlation. Next one, linear correlation and non-linear correlation. The first one, linear correlation. If the ratio of change between two variables is uniform, there is a linear correlation between them. For the given x, y variables are there. For given x variables values 1, 3, 5, 7, 9. So there is a uniformity in the x variable, and see the y variables 2, 4, 6, 8, 10. So the y variables also have the uniformity in the variance, the values. So this is the example for linear correlation. So next one, non-linear correlation. The amount of change in one variable does not bear a constant ratio of the amount of change in the other variables. So linear correlation means it is opposite to the, sorry, non-linear correlation means it is opposite to the linear correlation. So here see the example x and y variables. So x variables 1, 5, 9, 11, 15. Here see the values, there is no uniformity in the x variables. Then see the y variables 2, 3, 6, 10 and 14. There is no uniformity in the y variables. So this is the example for non-linear correlation. So linear and non-linear correlation is over. So these are about the types of correlation. There are four types of correlation: positive and negative, simple and multiple, and total and partial, then linear and non-linear correlation. So next one, method of studying correlation. There are two methods, graphic method and the mathematical method. So in the graphic method, we are using scatter diagram to find out the correlation. In the mathematical method, we are using formula to find the correlation coefficient between the variables. We are using Pearson's coefficient of correlation and Spearman's coefficient of correlation. Let's see one by one. So before going to scatter diagram, first we will see the properties of correlation coefficient or numerical value of the correlation coefficient. The first one, the R, the Karl Pearson coefficient of correlation always denoted by R, which means correlation coefficient is denoted by R. This R is always lies between -1 to +1. So that is the given in the first property. The coefficient of correlation R lies between -1 and +1. If R equal to +1, which implies that there is a perfect positive correlation between variables x and y. The next one, if R equal to -1, there is a perfect negative correlation between variables x and y. So this is the negative correlation. Then next one, R equal to 0. If the two variables are uncorrelated, that is called the no correlation or uncorrelated, which is R equal to 0. So next we will see the scatter diagram. So scatter diagram. So here we have three diagrams. First one is positive, second one negative, third one no correlation. Based on the property, we can see this scatter diagram. So if we have x and y variables, the x and y pairs of variables plotted on the graph, that is the scatter diagram. So plotting the points on the graph, we get the x and y variables, whether it is positive or negative, there is no correlation. We can find with the help of scatter diagram. So this is the scatter diagram. So first one, positive correlation. So already we have seen about positive correlation. If x and y variable increase on the same direction, or if x and y variable decrease on the same direction, which is called the positive correlation. For example, we have seen that rainfall and yield of crops. So then in the properties we have seen that r equal to plus 1, which means there is a perfect positive correlation between x and y variables. So this is the example for r equal to plus 1. The next one, negative correlation. So negative correlation means if x and y variables um, moving together in the opposite direction, which means x variable increase now, y variable decrease. Suppose x variable decrease, y variable increase, that is the negative correlation. If r equal to minus 1, there is a perfect positive correlation. For example, we have seen that demand and price. So this is the negative correlation. Then next one, no correlation. Here we are plotting them x and y variables. See that variables in the diagram. So it's in the sheet, all the points are spread over the graph sheet. So there is no correlation. We cannot find the correlation between x and y variables here. So in the properties given, r equal to 0 means uncorrelated or no correlation. So this one is the example for no correlation. So this is the scatter diagram. With the help of scatter diagram, we can study the correlation coefficient. Coefficient is it the graphic method. So next one, mathematical method. So first one we are seeing about Karl Pearson's coefficient of correlation. So the given problem, calculate the Karl Pearson's coefficient of correlation between x and y from the following data. They given for x and y variables. For x variables values is 1, 3, 5, 7, 10. Then y variables values 2, 4, 6, 8, 10. Then okay. Then now going to solution. So first we will see the formula for Karl Pearson's coefficient of correlation. Small r equal to n into sum of xy minus n into sum of x sum of y divided by square root of n into sum of x square minus sum of x the whole square into square root of n into sum of y square minus sum of y the whole square. Here n is the number of observations. So for x and y variable, how many observations are there? 1, 2, 3, 4, 5 observations. Then remaining part we have to calculate sum of xy, sum of x, sum of y, then sum of x square and sum of y square. Let's see that calculation. So for the calculation, first we take the x values, then y values, then from the x values, we are squaring the each and every x variables. We get the x square variables. For squaring 1, we will get 1. For squaring 3, 9. 5 square 25. 7 square 49. 10 square 100. Then next we take the y variable. So the given y variable, we are taking square for each and every y variable. So first one, 2 is square is 4, 4 square is 16, 6 square is 36, 8 square is 64, then 10 square is 100. The next one, x and y. Here we are multiplying x and y variable. 1 into 2, 2, 3 into 4, 12, 5 into 6, 30, 7 into 8, 56, then 10 into 10, 100. So from this we can find the sum of x value is 26, sum of y value is 30, then sum of x square value is 184, then sum of y square value is 218, then sum of xy is 200. So now substitute all the values in the formula. We will get the correlation coefficient between x and y. So now come to this result. R equal to, for here 5 means n. N into sum of xy is 200 minus sum of x is 26, then sum of y is 30 divided by square root of n means 5 into sum of x square value is 184 minus sum of x value is 26. We are squaring 26 into square root of n is 5 into sum of y square value is 220 minus sum of y value is 30. Here we are squaring sum of y value. Then after simplification, we can get the Karl Pearson coefficient of correlation, that is R equal to 0.9959. So this is the positive correlation. Suppose if the value come from negative sign means that is called the negative correlation. So next we will see the another method of rank correlation. So before going to that rank correlation, first we will see the what is quantitative data and qualitative data. So we all know about that quantitative data, qualitative data. So quantitative data means which is measurable. Qualitative data means which is not measurable. From in the quantitative data means, for example, height and weight we can measure it. That is the quantitative data. In the qualitative, for intelligence, beauty, IQ, so these all we cannot measure it. So that is the qualitative characteristics. So we suppose if we have qualitative data means we can use the rank correlation to find the correlation between given variables. So now come to the rank correlation. This measure is useful in dealing with qualitative characteristics such as intelligence, beauty, etc. Rho equal to the Spearman rank correlation denoted by rho, which is equal to 1 minus 6 into sum of d square divided by n into n square minus 1, where d equal to x minus y is the difference between ranks of corresponding pairs of x and y, then n is the number of observations. Now see the problem for rank correlation. So the given problem, the following are the ranks obtained by 10 students in statistics and mathematics. So for the statistics, they given 10 values 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. In the mathematics ranks values 1, 4, 2, 5, 3, 9, 7, 10, 6, and 8. To find this Spearman's rank correlation, so first we so first to find the Spearman's rank correlation, so we have the some step to calculate Spearman's rank correlation. Well, let's see one by one. First to solution. So first we write the formula. We already know this formula. Then next is the calculation part. Here the given x and x is the statistics and y is the mathematics. We are taking x and y variables here. The next one is t equal to x minus, which means difference between x and y. So x 1 minus 1 is 0, 2 minus 4 is minus 2, 3 minus 2 is 1, 4 minus 5 is minus 1, 5 minus 3 is 2, 6 minus 9 is minus 3, 7 minus 7 is 0, 8 minus 10 is minus 2, 9 minus 6 is 3, 10 minus 8 is 2. Then next square this d values, 0, minus 2 square 4, 1 square 1, minus 1 square 1, 2 square 4, minus 3 square 9, 0 square 0, minus 2 square 4, 3 square 9, 2 square 4. Now we add all the values, we will get the sum of d square equal to 36. So now substitute this value in this formula. Rho equal to 1 minus number of observation is sorry 6 into sum of d square value is 36 divided by n is 10 into n square minus 1 is 99. After the simplification we get rho equal to 0.781. So here also we get the positive correlation. Suppose if the rank come negative means the result come negative value means it is a negative correlation. Then one more thing, so in this video we are seeing that only the rank correlation only when ranks are given. I took the example for in this video. Suppose if the rank are not given, if the rank are repeated now, we have another form, we have another procedure and formula for that. So if you want to know about more about this correlation, you can refer this book. Thank you for watching this video. Thank you.